Good evening, everyone. Welcome to the fourth problem. This will be published tomorrow. This problem was once again for IB2 students. This is on rotation. Okay. Now let us start with this. This problem will be published on Thursday. That's on 3rd of October. Okay. This question is for 10 marks. So I have allotted 10 minutes for this problem. A student models a rotating dancer using a system that consists of a vertical cylinder and a horizontal rod using two spheres. Okay. So you have a vertical cylinder and two spheres over here. So the dancer can rotate, can stretch her arms, can bring the arms together and so on. So this is how it has been modeled over here. The cylinder rotates from rest above the central vertical axis. Rod passes through, let me start this. Through the cylinder with a sphere on each of the side of the cylinder. Each sphere can move along the rod. Initially the spheres are closer to the cylinder. So as this rotates, there's a possibility that these spheres can move. Okay, so based on our interest we can move this across here. Now the horizontal force of 50 Newton is applied perpendicular to the rod at a distance of 0.5 meter. Okay, 50 Newton is applied here, and another horizontal force of 40 Newton is applied in the opposite direction from the central axis. Air resistance is negligible. Okay, so one force is acting like this, one force is acting like this over here, the other force is acting downward like this. Okay, and then as a result of it, what can happen? If you have an object like this, you apply a force here, you apply a force here, this can now rotate like this. That's possible. Now what else has been asked? Now show that the net torque on the system approximately is 30 Newton meter. You need to find out the net torque. What is torque? Torque is given by two formulae. One is, you can write torque equal to I into alpha, and you can also write torque equal to force multiplied by displacement or distance or perpendicular distance. Now this is the force applied here, and the perpendicular distance above the pivoted center is this your distance over here. So torque due to this force, okay, what does the torque do? Torque rotates the object. So now this force, when you applied above this center, is now able to rotate this rod in this direction, right? So therefore, let us write down what is the torque here. So let me write this as a tau 1, torque 1. Torque 1 should be equal to 50 Newton multiplied by R. What is R here? R is the distance here, perpendicular distance, which should be 0.5. So which should now be equal to 25. This is Newton, this is meter, is 25 Newton meter. This is what the torque due to this object. Now in addition to this, there is one more torque acting here. There is one more force acting here, which is making it to rotate like this over here, right? This object. So you see, this is rotating like this. This is also rotating like this. So both the torques are now adding up together to give rise to a net torque, right? So therefore, now what is the torque due to this one? Let me write it down here. So tau 2, torque 2 is equal to, let us say F1 here, F1 R1, and this should be F2 R2 here. What is F2 here? F2 here should be is 40 Newton. 40 Newton multiplied by R2, perpendicular distance here. What is the perpendicular distance? 0.2 multiplied by 0.2. So which should now be equal to 8 Newton over here. Now how is the torque acting? See, if one torque is making to rotate like this, other torque is also rotating in this way. So which means what's happening? The torque is enhanced, the torque is increasing, right? So what should I do? The total torque should be sum of these two, which should be 25 plus 8, which should be 33 Newton. Okay, now let us read the question once again. What does it say? Show that the net torque on the system above the central axis is approximately 30 Newton meter. So we have got 33 Newton meter. So we already proved this over here. Okay, now let us move on to the next question. The system rotates from rest and reaches a maximum angular speed of 20 radians per second. Whenever there is a question on from rest, what does it tell you? That initial condition is equal to 0. Now it's a question on rotation. So when it is a linear problem, initial velocity is 0. It's a rotational problem, initial angular velocity is 0. So which means omega I is equal to 0. Reaches a maximum angular velocity 20 radians per second. Omega F is given to you in a time of t is given here, which means there if u, v and t are given, what will you find out? You will find out the acceleration. Here omega I, omega F, t is given, what will you find out? Angular acceleration. So this angular acceleration alpha is equal to omega F minus omega I divided by t, which should be, what is omega F? Omega is 20, then omega I is 0 divided by time taken, which is 5. So answer should be 4, and 5 ones are 5 fours are, right? 20 by 0 is 20. So 4, and what's the unit here? So what is the unit here? This is radians per second. I copied this radians per second here. Radians per second. divided, what is the unit here? Second over here. So this should be 4 radians per second square, right? So this is what we have got for value of alpha. Okay, now let us look at the next one. Determine the moment of inertia of the system about the central axis. So about the central axis, moment of inertia. How is the moment of inertia defined about this point? Moment of inertia for this point is defined by m1 into, so this is the point particle, right? If it's a point particle, then it is rotating like this. You should get m1 into r1 square. Is the mass given here? Is the mass given here? Mass is not given, only force is given over here. Okay, so you need to talk about the moment of inertia of this one. So usually moment of inertia of this particle is given by m1 into r1 square. R1 square, this is your r1 square, and similarly m2 into r2 square, because they are at equal distances you can find, but unfortunately m1 is not known, r1 is not known, nothing is known. See, this r1 does not refer to this one. Okay, it refers to distance between the pivoted axis and the center of the sphere. It is not given, so you cannot find like this. There is another way to find out the moment of inertia. How do you find the moment of inertia? So we know that tau is equal to, or what you call it as, the total torque is equal to moment of inertia total multiplied by the angular acceleration. What is the value of total torque? We already found out. Where is it now? Total torque is 33 Newton meter. We already found out that the first part. So we'll write 33 here is equal to moment of inertia. I do not know what is this value. What is alpha? Alpha is angular acceleration, which we got this as 4 multiplied by 4. So therefore I should be equal to 33 divided by 4. What is the value? Let us calculate this. Let me take calculator. 33 divided by 4 will be 8.25. So I get the answer here as 8.25. What is the unit? This should be, what is moment of inertia given by? This should be kg into meter square. Why? Mass into radius square, distance square. So therefore I will write this as a kg into meter square, right? 8.25 kg meter square. Let us move on to the next question. Next. When the system has reached its maximum angular speed, the two forces are removed. The spheres now move outwards, okay, away from the central axis. When it is rotating faster and faster, what can happen? Okay, the spheres, there are no friction over here, so it is now started to moving away over here. Okay, it's moving farther away. It's something like you have a disc. Now when you start rotating and you put a paper piece, what will happen? The paper piece will move outwards, right? The same thing is happening over here. Outline why the angular speed omega decreases when the spheres move outwards. When the spheres are moving outwards, why should the angular speed decreases? That's the question. Now, how do you answer here? So what we need to do is, so see, now is there an extra force acting here? There is no extra force which is pulling it outwards or downwards over here. So there is a conservation of angular momentum being seen. Okay, what do you mean by conservation of angular momentum? Conservation of angular momentum tells you the angular momentum before applying a force or before a collision is equal to angular momentum after a collision. That's what. See, similar to that of your conservation of momentum principle, this also applies over here. But we don't have a collision over here. So what's happening over here? So there's a movement over here, right? You remove the force. When there was a force, okay, it was the moment of inertia. The objects were nearby over here. It has some moment of inertia. When the object started moving, when the distribution of forces takes place, then what can happen? The masses started moving away here. Then as a result of it, the angular velocity will now reduce. So you need to write it in two statements here. The first one is conservation of angular momentum tells you that angular momentum is conserved. Now how is it conserved? Angular momentum is given by the formula. It should be I into omega. What is I? Moment of inertia. What is omega? Angular velocity. When the masses move apart, okay, initially when the masses were here, what was the moment of inertia? Moment of inertia at this point was seen to be m into r square. What is the moment of inertia here? M into r square. When the masses moved apart, what is happening over here? Is the mass changing? Mass is not changing, but the distance definitely has changed, right? Distance has changed. This has been different over here. When this has changed, then automatically what happens? So the moment of inertia changes. What happens to the moment of inertia? It has increased, right? It has increased. When I increases, then automatically omega should decrease. Why should omega decrease? Because the value of I into omega is a constant. It is like writing, let us say for example, I have a number like 100. Okay, How do you write the number 100? You can write the number as 2 into 50. Okay, assume I is initially 2, omega is 50 over here. Now you can also write this as equal to 4 multiplied by 25. What's happening? I is increasing, omega is decreasing, right? You can also write this as something like 10 into 10. Now again what has happened? I is increased, omega has decreased once again. See, 50 to 25, 25 to 10 it has come. Now still if you want to do it, let us say you can also write it as 20 multiplied by 5. What do you mean by that? Which means I has become 20, omega has become 5, such that the product will always seem to be a constant. Okay, so that's the reason why the angular velocity decreases when there is a distribution of the mass. So you should write both the conditions. What should you write here? You should write, first one is when the spheres move apart, masses are moved apart and distance increases. So the consequence is moment of inertia increases. When moment of inertia increases, automatically the angular velocity should decrease because conservation of angular momentum is followed. Okay, you should write so much. Then next question, show that the rotational kinetic energy is given by half L omega, where L is the angular momentum of the system. Okay, what is rotational kinetic energy? Rotational kinetic energy is given by half I omega square. I can also write this as half into I omega into omega. Now what is I omega? We already seen this is your angular momentum. So I will write this as half into L into omega, right? We have proved this one here. Then let us move on to the next one. When the spheres move outward, the angular speed decreases from what is given here. So it is omega I. Omega I is given 20 rads per second to 12 rads per second. Omega F is given. Calculate the percentage change in the rotational kinetic energy that occurs when the spheres move outwards. What is the percentage change? First, what we will do is let us find out what is the moment of what is the kinetic energy. What is the kinetic energy? Okay, when the value of omega changes. So kinetic energy, as we know, is given by half I omega square, which should now be equal to half into L into omega. How do we know this? We already got it from here. Okay, remember in IB, all the questions are framed in such a way that the answer you got previously will give you a clue in the next question. So I have taken this answer. Kinetic energy is given here. I have taken from here half L omega. Now therefore, let us take two kinetic energies. Kinetic energy initial. What is this now? My angular momentum will not change. I told you already, it does not change. So kinetic energy initial should be proportional to omega initial, which should be, now what we will do is, let us say since this is going to be a constant, I will write this as k times omega. Okay, so I will just write this as kinetic energy is equal to k times omega 1, which should be equal to k times, what is omega 1? 20. Okay, what is kinetic energy final? Kinetic energy final is equal to k times omega 2. What is omega 2? Omega 2 is nothing but 12 over here. 12 over here. What is the difference between these two? Okay, I can now say, or I'll say kinetic energy initial delta Ke. Delta Ke should now be equal to K into 20 minus 12, which should be equal to K into 8. Now what I will do is I'll take the actual initial kinetic energy, divide this Ke initial I will do. When I do this, what do I get? I'll write this as K into 20 over here. Initial kinetic is K into 20, right? I'll write like this, K into 20. So this K goes away. 4 2s are, 4 5s are, which should now be equal to 2 by 5, right? So 2 by 5. Why did I do this one? Because what is being asked is asking you percentage change. What do you mean by percentage change? Percentage change is obtained by delta Ke divided by Ke multiplied by 100. I hope you understand this from your error perspective. Okay, you have learnt about relative error, percentage error. This is the same thing that is being asked over here. Okay, so therefore 2 by 5. What is 2 by 5? 2 by 5 is nothing but 0.4. Okay, if I multiply this by 100, I get the answer as 40%. Thus the answer here is 40%. Okay, so I hope you have understood the questions, how to solve this. There is one more question over here, I think. Yes, outline one reason why this particular model of a dancer is unrealistic. What is the reason? The reason is because it is something like when a dancer is moving. So what you can do? She can stretch her hands like this. She can bring it nearby over here. Okay, but here what happens is when you have, this is your cylinder, this is your rod over here. Okay, there are two spheres over here. This spheres can actually move like this and like this over here, but there's a friction over here. We are ignoring the friction. We are ignoring the friction which should be considered. Okay, and we are not also considering the masses over here. Okay, the mass of the object. You can write all this. Maybe there's also an air resistance, right? When there is something like movement over here, there can be wind blowing on some direction. So as a result of it, the direction of the rotation can also hamper, right? You can also put air resistance. Thus all these terms will contribute or will say that the mechanics that we have described here is unrealistic. Okay, so therefore this is what are the factors that you need to put it across. Okay, so with this we come to an end to this particular problem. Tomorrow we'll see with one more problem. Okay, hope you're solving the problems clearly. So without looking into the videos, first you solve this and later on you can look into the videos to get the answer. This question on rotation is considered to be one of the most easiest questions. Okay, so let me stop here and continue in the next class. Thank you.